So I have some diet soda here. We're going to call it Diet Dr. Thunder. And this is just regular Dr. Thunder. And I want to show you something very interesting about them. This would work with Diet Coke and Coke, Diet Pepsi and Pepsi. Let's see if you can't figure out what's causing this. So it appears that the diet soda is floating while the sugared soda has sunk down to the bottom. Why? A Coke can and a Diet Coke, and it doesn't matter that I was using Dr. Pepper and Diet Dr. Pepper, it would have worked the same way. So you put a Diet Coke and a Coke can in a container of water, and voila, the Coke can sinks down to the bottom. The Diet Coke is going to float on top. Why? Well, year after year, kids raise their hand and they ask me, is it about the can? Is there a difference in the can? And I would say, no, the cans are exactly the same. They ask me about the paint. Could it be that the paint on the Coca-Cola can makes the difference? Nope. The paint, irrelevant. So what is causing the Diet Coke to float while the Coke sinks? Well, obviously has something to do with, yes, density. Obviously, altogether, the Diet Coke is less dense than water, and Coke is more dense than water. But the question is, why? People always ask me, could it be that there's more air in the Diet Coke? Ooh, if there was more air in the Diet Coke, then yes, it is entirely possible that Diet Coke could be less dense than water. Obviously, that's what happens with boats and ship. Even though the boat and the ship material may be more dense than water, then obviously the ship or the boat, along with all the air that's surrounding it, that's inside of it, is going to make the ship in general to be less dense than the water. Same amount of gas for both of them. That's not it. What else could it be? Well, as you see before you, the only basic difference between Diet Coke and Coke is the sweetener. In Coke, they're using this poison, and I am not exaggerating, high fructose corn syrup, HFC, is a poison. It is very sweet, has absolutely no nutritional value. Its job is to trigger the sweet sensation, the sweet taste in your mouth. That's it. That's it. It's actually very bad for you, and it will be converted into fat very, very quickly, especially the older you get. So, Coke has its sweetener is high fructose corn syrup. So immediately people ask me, could it have something to do with the fact that the high fructose corn syrup is heavier, more dense than the sweetener that they use in the Diet Coke? And as you can see from my numbers here, the answer is no. High fructose corn syrup has an atomic mass of 198.7 grams per mole. Now, you don't really know what that means, but you will eventually. The number is the key. It's a bigger number than what's on the right. What's on the right? Well, the sweetener that they use in Diet Coke is called aspartame, and you see the structure there. Aspartame actually weighs more. So the one that floats has a sweetener that weighs more and is actually more dense than the sweetener that is in the can that goes down to the bottom. So the mystery continues. What could it be? What could it be? Eventually, a kid asked me, do they have the same amount of sweetener? And that's when I go ding, 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 ding. Okay. Does aspartame have calories? Can it make you fat? Yes, it can. It has a caloric value. Why do we put it in Diet Coke? Because the key to this whole puzzle is the fact that aspartame is so much sweeter than sugar that you simply do not need as much sweetener. So the difference is that you have a tiny little fraction of aspartame compared to high fructose corn syrup. In order to give you the same amount of sweetness, you only need a fraction of aspartame. And that is the secret. Aspartame, you only have a tiny amount of aspartame. You have a huge amount of high fructose corn syrup. So together, the cans, if you were to weigh the cans together, weigh the cans at the same time, you would find that the Coke can is quite a bit heavier than the Diet Coke. Why? Because you need a whole lot more high fructose corn syrup than you need aspartame. So remember, the density is mass per volume. They each have the same volume. Coke has more mass, therefore, Coke is more dense.